morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. In this video, we are going to look at the subtopic, the scalar or dot product of two vectors. So the scalar or the dot product of two vectors. Then we have these three practice questions. Question number 1 will be answered in this video. Question number 2 will be answered in a separate video. And question number 3 will also be answered in a separate video. So in this video, it says, if vector P is equal to 3i plus 4j and Q is equal to 2i minus 3j, we need to find P dot Q. So for A, for information, first of all we know P is equal to 3i plus 4j, then we have our Q is equal to 2i minus 3j, like that. Then we need to find the P dot Q. So P dot Q is equal to question mark. What do we do for that? So this is question number A. To find P dot Q, first of all, let's write this. So we get this part. We substitute the P with that. So 3i plus 4j in brackets like that. And then after writing 3i plus 4j like that, you can put another bracket to represent the Q here, this part here. So 2i minus 3j. What we do here is need to know the properties that I explained earlier. So I said I squared is equal to 1, j squared is equal to 1. I times j is equal to 0. These properties are very important. So vector I times vector j is equal to 0. Right. It follows the thing that if we have a right angled triangle, alright, and then we have perpendicular vectors, their dot product is 0 because the angle there is 90 degrees. So think of it like this. This is representing direction in the y-axis, so j, this is the in the x-axis I. Then the angle between them is 90 degrees. Then cosine theta has a wave like that. So cosine theta has a wave like that. And then when it comes here, it is 90 degrees. Then from here, it begins from 1. So which is somewhere 0. Okay? So like that. So it passes there. Then it will go to its lowest point somewhere there. What I'm just trying to say, don't focus on this curve a lot. The curve, it is like this. But where it crosses right there, x-axis, it's at 90 degrees. Then it goes to 180 degrees. Then back here to 70 degrees. Then 360. But this is not for this video. Just know that this cos 90 is 0. So therefore, if we say I times j, it should give you 0. That's why I times j is 0. Alright. So we expand this bracket knowing fully that I times j is 0. It will be, it means let us just multiply this right here with this. And then 4j you multiply by that. Because we know that when we multiply two of them, it should give you 1. Now if you multiply 3i by negative 3j, it will give you 0 because I times j is 0. So this will be equal to 3i multiplied by 2i is 6i squared. And then here we're going to have minus 12j squared. This is the same as 1, then minus 12, same as 1. This is 6 minus 12 equal to negative 6. Alright, so since now we know that I squared, this is 1, and this is 1. So these steps right here the above steps are not necessary. Just say 6 minus 12, it is negative 6. And that's the final answer for question A. For question B, we are proving that these are commutative. Commutative just means A dot B is equal to B dot A. So if they tell you to evaluate Q dot P, so they are saying you start with this part, which is 2I minus 3J, then you multiply by 3I plus 4J. This will still say 2 times 3, which is 6, negative 3 times positive 4, negative 12, which will be negative 6. So your final answer is negative 6. So just want you to evaluate to prove that they still give you the same answer if you start with the other bracket. Thank you so much for watching. This has been Cornelius Luvinda with another video, and bye-bye.